Hi, good evening, everyone. Very warm welcome to the second keynote session of today. So before we start, we encourage everyone to type in your question in the question chat window while the session is going on. Okay. Today we have Paul Hammant with us for the second keynote session. Just a brief introduction about Paul. He's having more than 30 years in the software industry and he's an ex-thought worker. And he is very famous on trunk-based development. He has written a book on trunk-based development and branch by abstraction. And he is also a co-creator of Selenium and FICO Container. With this note, I welcome Paul Hammant to this session, and over to you, Paul.
Okay, well, thank you very much for having me. It's a pleasure to be on this this conference, especially in these times. Following on from Dave is a big thing to do. I do remember interviewing Dave for ThoughtWorks. I don't know how long that was, maybe 15 years ago, and he was a person that lifted the bar when he came into the company, and we were greatly beneficial of his skills and expertise and achievements as went forwards after that. Okay, so my presentation. A spoonful of shift rights with that bucket full of shift left. I have here on the screen a little presentation of a balance with a bucket on it, and then something maybe smaller further out. And if everyone's understanding how weighing scales work, then the little thing on the right is balancing the thing that's bigger on the left. Anyway, can't work out how to move my slides forwards. There we go. So I'm a trunk-based development expert. I'm now an author on the same topic. I'm Selenium co-creator as mentioned. I've been coding for a long time. Otherwise, when I'm not coding, I'm an architect or a troubleshooter or an executive, CTO, chief science officer, or a startup co-founder. I'm also, when I was flying, a legacy application rejuvenator for corporates. Now I do that on Zoom. I have a bunch of links if people wanted to go there. So I have a roadmap, maybe a representation of what we're about to see. So we've got 6 slides of context, 6 slides on the defect in that bucket full of shift left, and then there's 4 slides on a spoonful of shift right. Fix that later, and then there's some more reading. So we'll dive into it. First off is context. Now, Barry Beam, and I'm sitting in Edinburgh now, and I first saw Barry Beam in Edinburgh speaking at an Agile conference or an Agile meetup in about 2002. And he came when he talked about his career accomplishments and some of the prerogatives for the Agile community around software economics, and his piece. It was the biggest contribution to the field of computer science was his book, Software Engineering Economics. And he'd done a breakdown of some US projects at the government level. Some Safeguard is a missile project, by the way, if you can see that in that picture. And looking at where the defects would crop up in the build out of these large systems and how much it would cost to resolve them. And he came up with this little table. It's been used a few times by others in conferences. But basically, across the bottom, we have requirements flowing into design, flowing into code, flowing into development, flowing into acceptance tests, flowing into operation and production. And his hypothesis was that if we shifted our defect resolution towards the left, it would be cheaper. And it was borne out by the statistics and the figures from this study. So I'm not going to go into it, you can go and find it. But basically our shift left thinking is either a representation of these hurdles, requirements into design, into code, into development, into acceptance testing, into operation, or it's an allusion to Gantt charts. But either way, left is what we like, and it's now an industry war cry. So we could recap and say that for ourselves, software development professionals, shift left is about moving things to the left as much as we can. And as the coders amongst us will think about test automation as our major place of saving of defects on a sooner is a cheaper basis. And we would like to do more defect resolution in development, which probably means we need better requirements or best requirements for the piece of work we're trying to do. And if we can't do that, or as well as doing that, we would also like to automate the tests of things, various bits and pieces. And we would like to do that in our own workstations rather than an over-the-fence activity that would have gone to a testing team. So we haven't eliminated those testing teams, we just have decreased our reliance on them. And we're trying to do as much as we can in a coded way that's in source control, that we'll wake up and activate as we do our work tens of times a day, hundreds of times a day, but definitely thousands of times before we go live, if our release cycle is slow enough at least. Dave was talking about Amazon pushing stuff out every 11 seconds, and maybe it's not running 1,000 times before each of those. Anyway, so we think of defects as things that are buggy in code, but defects can also be in requirements, and we're going to not talk about the improvements that product owners and business analysts can make, but we're going to know that they are real. So let's dive into our view of test automation. What I have here is a representation of 1, 2, 3 builds: build 100, build 101, build 102, and in order, in a pipeline, we would see compile, followed by unit tests, followed by service tests, followed by functional tests, followed by a binary distribution or a deployment to a system. System could be QA or UAT or even production, depending on which flavor of CD you're doing, as Dave mentioned. Now, in these three that I have here, we're implying that build 100 and build 101 went all the way through perfectly. There's some time spans across the top there. Maybe your builds are faster, maybe your builds are slower. If you're in a large legacy bank, your builds are probably a lot slower than those for each of those steps. Build 102 failed at the service test phase, which is why that's red. And if it fails there, it doesn't go on to do functional tests. Each of those is a gate in a build pipeline, and it certainly didn't do a binary distribution or deployment. In my travels, people ask me what percentage of red versus green do I accept in QA automation, and the answer is I accept 0% red, and that sometimes shocks people because their bosses have told them to accept 80% green and 20% red. But anyway, underneath unit tests, we might characterize each of those, it could be hundreds or thousands, that they are less than 10 milliseconds each, and they do not do I/O. So they don't read from files and they don't do TCP/IP on any basis. That gate passes, say, and we fold into service tests, which is one of 2 classes of integration tests that I'm showing here. We could say that service tests take less than 100 milliseconds each. And they do I/O, and they're going to do some invocation of some service towards some provable satisfaction in assertions. And that could be TDD, or it could have been developed BDD, maybe both sometimes. And it could have used Cucumber, or it could have used JUnit or equivalents, and it doesn't really matter as long as it's an assertion around something that's valuable. Then the next gate after service tests, in my worldview, is functional tests, as done by Selenium WebDriver or equivalent. So that could be Appium, or it could be a number of fat technology testing frameworks like Flutter is a UI technology from Google for fat clients, and they have a Flutter driver that's reminiscent of some of the pieces of Selenium that allows you to poke a Flutter application programmatically for the sake of test. This passes, this fails. Now, we might think that functional tests will take less than 400 milliseconds each. Some people on this presentation listening might think each of their tests takes 5 seconds each. Well, then there's some room for improvement there, and a whole bunch of techniques that you can make those faster. But Selenium is a done deal. We made that in 2004. I'm co-creator. It kind of is the de facto standard now for testing. There are younger web clicking assertive technologies, but Selenium is still the the de facto choice for enterprises. And we might wonder, what else happens in respect of your CI and build pipelines? And we might remind people there are some assumptions. Both Dave and I will agree that we sit all of our best practices on top of trunk-based development. And if we can, we will do build automation in some scaled infrastructure that can try and keep up with each commit individually. 10 years ago, maybe more, 15 years ago, we might have been batching 10, 20, 30 commits in one build. And then if that failed, we had to pick it apart and find out which of those 10, 20, 30 caused it to fail. But either way, let's say today, 2020, we can do one automated build in our Jenkins style infrastructure per commit. So a reminder, the build is a term that's been used by dev teams for a few decades, but I think it's important to point out that the build is more than what we used to remember it to be. It is and remains a thing that can run in the Jenkins style infrastructure after commits have happened. But the build is something we can also do and should also do on our developer workstations, and that includes test automators, before we commit and push into source control and thus triggering the Jenkins style CI infrastructure. And this one's important because as many enterprise teams don't have that capability, they have to do the commit push and then they have to wait to find out whether it was good or bad. Dave likes flow-centric methodologies. Perhaps one of the original ones was extreme programming. Extreme programming teams didn't even have a Jenkins to make their stuff work for them. They'd do all of their practices as human activities. Two people would check something in and they'd run the build on their workstation or their laptop. And they'd run it before they did their merge into the trunk or mainline. And it always worked. So they wouldn't push that into the shared place if the build didn't pass, and the build would incorporate unit tests. The origins of the origins of extreme programming were in the Smalltalk community, but then rapidly at the end of the 90s became a habit for Java-based teams first, and then other languages afterwards. So a rule for both. The build should be able to pass without dependence on any external services. So that would be external to the machine, and the machine is a broad term. Could be a VM, could be a container in the Docker style, could be a laptop or a proper dev workstation. It doesn't really matter, but the build should pass regardless of the status of other services on other machines. So I think reasonably we pull our dependencies from Maven Central or from one of a number of package managers inside corporations and maybe sometimes on the internet. And once we fill those caches, we should be able to disconnect from the network, i.e. turn off your Wi-Fi, rerun the build and observe that it still passes and possibly runs just as fast as it did when we first ran it. Maybe faster because we filled our caches. So there's a rule, right? The build for humans, developers, test automators, and for build nodes within a scaled CI infrastructure should run without dependence on any shared services anywhere. And a proof of that would be disconnecting the network and rerunning the build again. So that's probably controversial to many enterprise and legacy teams, but it's an objective they should try and reach, be able to run that back to back after unplugging the network cable. So let's tie back, we're still in context. Let's tie back to Ken's closing shift left questions yesterday. So he left us with a question around challenges. What challenges do you think we'd face in adopting behavior-driven development or acceptance test-driven development? What challenges do you think we'd face adopting test-driven development? What challenges do you think we'd face adopting hypothesis-driven development? So he left us with these questions as he closed out his presentation. And it's a useful segue for me as we go into, I think, in everyone's top three, and really people can draw up a long list of challenges in that regard. But I think one of the challenges that we have is integration tests are slow and flaky. So we gave you two classes of integration tests. They were the service tests and then the functional tests. And if we have on the left here a hypothetical application tiered in a number of ways, we could see that some part of it runs in the browser on the user's machine. Some part of it is the back end, itself tiered into a REST layer, business logic layer, service and persistence layer. And then that as a back end in itself, especially in this microservices era, could be depending on other shared services. So just euphemistically written there, sometimes my backends have backends. So that's the reality in many enterprise organizations and possibly also the reality in startups. And then it leaves us with a testing challenge around integration tests. If they're slow and flaky, we tend to maybe think we shouldn't run them and that we'd be better off throwing stuff over the fence to a formal testing team on a just-in-time basis before we go live. Anyway, so service virtualization to the rescue, right? So service virtualization is an established class of software. It's maybe 8 years old. There are commercial players. There are open source pieces. And like Selenium, over 10 years ago, usage of these technologies and techniques enable us to deliver that big shift left thing. You know, we can eliminate or downsize the team and time commitment in a development cycle for testing. When we've stopped it being formal and we've moved it up to being automatic, we can, despite the cost of writing it, we can inexpensively run it hundreds of times. Maybe still requires tweaking every now and again to keep it working, but as an investment, it's always a good one. So remembering that stylized application, front end in the browser, a back end, I've chopped off the other back ends. But either way, I have an application that we would put live, represented on the left, and then resurrecting some of those gates from the pipeline that can either run on your dev workstation or can run in the cloud in your scaled CI infrastructure. We've dropped off the compile, which was number one, and we've looked at number two here as unit test, but then decided not to really drill into it because I think everyone understands what pure unit testing is. But let's remind ourselves they're less than 10 milliseconds each and they don't do I/O. But then the two problematic ones, right? So if we're using service virtualization, how do we make them less problematic? And the answer is we might use rest assured to poke programmatically. Rest assured is a Java technology. There'll be alternates here for other technologies. We would use a programmatic testing technology to poke our service tests, emulating maybe some of what the browser would do. So we have this thing, and it's going off to do that I/O, and it could be give me something based on a zip code, add something to the shopping cart. It doesn't matter. Whatever our application is, it's represented by hundreds or thousands of HTTP I/Os between an imagined browser that's missing in this particular step 3 and a real REST layer. And being good test engineers, we've chopped off the next level down, which was business logic, which was going to be tested to a very high code coverage level in the unit test step. In this case, we're chopping it off and putting in a mocked business logic technology. And this isn't necessarily new. This is going to be something classic like Mockito or PowerMock or something like that. There's hundreds different technologies here for various languages. But what we really want to do is test the REST layer. So over HTTP, it's disqualified as a pure unit test because it's actually invoking I/O. But we can programmatically test every permutation that would be important to us. Log in, log out, is logged in already, add to the shopping cart, purchase shopping cart, can't purchase shopping cart because item is no longer in inventory. A whole bunch of fine-grained tests around our business represented by wire operations in HTTP. And then if that one passes, we fold into the next step, which is the functional test. Again, I'd use Selenium. You know, it's a fairly easy choice for me. Others would use some of the alternates in the modern era. There's some Chrome-only technologies, but if you're doing fat clients, you can't use Selenium even. You'll have to use something that's kinder to the WPF or the Swing or the Flutter way of working. So in the Selenium way of working, we're going to crank up a browser and we're going to load the actual front ends, HTML, CSS, and JavaScript into the browser, and we're going to poke it programmatically, maybe a bunch of similar operations to the ones we've done in the service tests. But in this particular case, we're only interested in testing the HTML, the CSS, and the JavaScript, and we're not interested in retesting the REST layer because that was adequately tested in the prior step. So we're going to mock it. And this is nearly always the case with a system under test. We have a thing we're trying to test, and we don't want to mock the collaborate. We don't want to test the collaborators, at least in this particular phase. And this is going to run once for every commit that gets pushed up, and it's also going to run, at least for the impacted tests, it's going to run once on the dev workstation, the developer's workstation, before they do the commit and the push. So, you know, we changed the nature of the stack that we're testing based on which of these steps we're in. Some production code is going to be tested always. Some production code is going to be missing through necessity, having already been tested in other steps of this build pipeline. So a recap, okay? So these little recap slides aren't because I want to read them out. They're because somebody might be looking at the printouts of this presentation later and they don't have the voice track. So, you know, that thing where we had the service test followed by the functional tests and we were using some mocking techniques gave us a new challenge. You know, we have some REST endpoints that are being poked in step 3. Is it step 3? I can't remember. The service tests. And then we don't have the same REST endpoints being poked in the next step, the functional tests. We've recoded them as mocks. And how do we keep the mocks in step with the real? You know, it wasn't answered. And it could easily go awry. And we could easily encounter a situation where all tests pass and the application goes live, maybe on one of the 2 CD style of deployments. But there's some bugs in there that aren't represented by failing tests. And that's problematic for us because we're now putting lemons into production. Business says to us, why did that happen? How did that happen? Maybe the business also looks at the build radiator and says, hey, that release, the build for it was green in every respect. All of those pipeline steps passed. And yet it went red in production. It was buggy in production, and we had to roll it back or do some emergency action to repair it in production very quickly. So the answer in this case was if we were depending on mocked wire HTTP interactions, we might have been out of step between the mocked interactions and the real interactions that would be used in production. And because we didn't test the real full stack in an automated cycle, we're at risk of encountering that on some percentage basis. So that's a challenge. And we have some mitigation for that. We could, in order to keep these mock HTTP conversations fresh, we could keep re-recording them. That way we don't go out of step between the real and the mock one. And obviously we're going to store stuff in source control. It's the same conclusion we reached for Selenium, that it was best in source control rather than a third-party tool, Windrunner being the third-party tool that we were trying to move the world away from, latterly known as QTP. You know, whilst we like the fact that we've got some recorded conversations in source control that we can use for fast playback for one set of tests, the cost of re-recording them defeats the purpose of benefiting from the recording, which would be faster and consistent. So there's the new logistical challenge. Recording real services is slow and flaky, even if the playback is fast and not flaky. And it defeats the purpose of using service virtualization at all. You know, mocking. Why mocking? So the mitigation for this is to re-record them outside the regular build. So the same automated infrastructure can run a job on some basis, but but it doesn't have to be inside the CI build, which is the one that's triggered by commits and pushes. And it doesn't have to be what the regular developers run themselves before they commit and push. And if you're recording your real conversations towards something that can be used from source control for fast playback, if your recording is different, then you can note that, and maybe the best way to note that would be a failure, a build failure. So if the recording is different, we get to investigate that, and that would be a human investigation. So build notifications, not the CI build, different build, wakes up, figuratively, I think, when you run this overnight, and then the person comes in the morning at 9 a.m., they work out that something to do with one of these recordings failed, and they should investigate it. So the CI build, the build, continues to use playback only and takes advantage of the fact that always passes and is always fast, or at least if it fails for some other reason that is also investigatable, but none of the flakiness or slowness manifests itself in the playback of service virtualized services. So I would suggest nightly, but I think if you're doing that, then you're really only going live once a week or once a month. If you're going live daily or 2 times a day, you probably want to run this hourly and investigate it very quickly if something doesn't record itself in a way that is predictable and deterministically proven in a unit test towards human investigation. So nightly just might be the most pragmatic frequency for a team that's delivering to production weekly or monthly or quarterly. If you're delivering quarterly, then maybe you'd run this weekly. Anyway, so we have new problems again as we solve each of these things for this idea of using service virtualization to make stuff real. So in our attempt to re-record the same service virtualization, we might encounter the fact that at least our testing version of that service is flaky. It doesn't always pass. It doesn't matter. As long as we can use retries, a very naughty technique normally, as long as we can use retries to get this to pass as a unit test, 2 + 2 = 4, and then assert it is 4. It doesn't matter that we had to try it 10 times before we saved it, but we did, and it did save it with the correct interactions, and we counted that as a good job. In fact, what we did was we used retries as a way of making our shaky, flaky, unreliable, slow QA versions of a service that maybe isn't flaky in production. What we did was we used retries as a way of making that look polished and smooth and fast and reliable and green the whole time. And we have another new problem, which is that humans may not be able to tell what is broken when this job does fail and say, I couldn't re-record this because it's different. And that is because maybe these service virtualization technologies don't have the easiest reports to read. And the solution for that one is use a format of service virtualization that is easy for humans to read. And as importantly, for humans to diff between an old version that purportedly was correct and a new version which is different and potentially broken. Git diff or subversion diff or whatever source control package you're in, diffing is a bread and butter activity for developers. They understand it, they're able to work with it, and if we've made the source format easy to diff, then we're aiding developers or QA automators doing some investigation as to why one of these re-recordings is different to what it was before. So anyway, what we've done is we've segued into this idea of a technology compatibility kit. And this is it's not a spoonful of shift left, this is the spoonful of shift right to be fixed shortly after this presentation. We have this idea that this other job that's non-continuous can run at intervals that gives us value, that doesn't slow down the main build, doesn't slow down the CI, doesn't slow down the throughput of the regular development team, but does provide a safety net. So some history of TCKs. Sun pioneered this this idea in 2004. They made Java, a programming language that's fairly popular still, and they made that in 1995 or 1994. And by 2004, they shipped some tests. They've been using themselves internally to prove that they hadn't broken Java itself, and they shipped them as a whole bunch of things that you yourself could use if you wanted to prove that Java was Java. Now, at the beginning, it was to prove that their Java, the one they made themselves, was in fact a version of Java. But sooner or later, other companies and open source groups like Apache would jump into the activity of making their own versions of Java, and they would use the TCK to prove that their Java was compatible with Sun's Java. Sun was latterly Oracle, of course, because of a takeover. So that's the idea of a TCK. Some would say this is contract testing in the modern age, but I'm just rolling back the years back to 2004 and saying Sun called it a TCK, and that's pretty good concept because you ship the reference implementation with the tests, and I think that has some legs. So I'd like to use the TCK terminology going forwards. And what we have described when we're talking about service virtualization is potentially the beginnings of a TCK for HTTP conversations. So there are many that pre-exist, service virtualization technologies. They typically record, if they record, they typically record their conversations in JSON or YAML. And I don't think that's very difficult, either of those two. Some don't even have a recording capability and are totally programmatic, meaning as a developer, you have to set up a whole bunch of expectations that will play themselves out over the wire for one of your test suites to utilize. Anyway, so I say, don't use any of those pre-existing technologies. Use Servirtium, which is something I've been working on with friends. And it's pronounced Servirtium, Service Virtualization IUM from, hey, we named Selenium. So I figured I'd borrow the IUM again and put it in here. And look, we have on the left there a Selenium-like logo. But anyway, this one records into Markdown. Markdown is a text language. It's fairly dominant for human written prose. So people write books in Markdown, they write blog entries in Markdown, they edit content for CMSs in Markdown in this age. Markdown will end up being the next Java or COBOL, and it'll still be in use in 30 years' time, and people will be rolling their eyes and wondering why. So we have for Servirtium, we've made a Java, Kotlin, .NET, Python, Ruby, Dart. Dart is the language that Scotch taped to Flutter, which is the new UI markup hotness from Google, JavaScript Node, Go, and Rust versions in progress. And recordings made in one should play back in another, which is the whole point. Your team might be a Java team making a service that a JavaScript Node team is going to consume later. And if you've gone and saved your recordings for them, then you've given them a boost in that they can use your pre-made recordings of various scenarios. They can use them directly in their own test base. And this is another open source thing. So I was in a stroke of genius moment in ThoughtWorks in 2004. We decided to open source Selenium rather than charge for it, and perfectly serviced the industry and avoided millionaire status for each of us individually or as a company. No regrets. And we're doing it again with Servirtium. ThoughtWorks is not involved. It's just me and friends. And we're trying to make an established standard around Markdown. And it could be that there are commercial vendors that will get involved and make their own versions of something that's Servirtium compatible, which is perfectly fine by me. But I think in the fullness of time, we're going to cover 5 or 10 more languages than we've covered here already, have alternates in each language, like 1 or 2 or 3 Python versions that compete or don't compete, as long as we all cooperate on a Markdown standard. So let's have a look at Servirtium's beautiful Markdown. So again, this talk is for technical, agile people who understand or can do or have once or previously participated in coding as an activity and commits, or still do. Anyway, so Markdown is on the left. It's human typed normally, but in this particular case, we're writing it from Servirtium. But it's human readable, definitely. we have a level 2 header, interaction 0, and inside that we have a level 3 header, request headers recorded for playback. And then we have a code block with 2 headers in it, which are contrived, and then a request body, which has some XML in it, which is also contrived. And that goes on for another 2 sections, but we're just showing the top half of a single interaction to path resource. And then, because this is Markdown and it's a well understood format, GitHub, for one, and others do the same, Bitbucket, they render it in a more pretty format. So the H2s and the H3s that are headings get formatted as H2 and H3 and HTML. Code blocks are given a little, I don't know if you can see it there, but it's got a little blue surrounds. I've clipped that from the web. And, you know, as you're reading this, you could say, maybe I understand this conversation here. Maybe you don't, like it could be 6 yards of XML or JSON or something else, or binary, which isn't so perfectly supported in Servirtium. But either way, as we look at interactions there, interaction 0 followed by interaction 1, 2, 3, 4, however many there are for one particular test scenario, we can follow what that means in terms of sections, headers, bodies, response headers, response bodies. So we like the Markdown. Here we've got another recap slide talking about, you know, the bits and pieces, and that it reminding us that it works at HTTP level. I've got some additional materials that are way too big for this presentation. They're blog entries, and we'll try and add the blog entries to the chat system or some distribution following this, or you could find the slides and then click on them. So this will take you off to a blog entry which has loads of pictures like this, and you can see at the bottom we've got again our compile, unit test, integration test, functional test, binary distribution thing where I'm stylizing some processes and some interactions for people that are 100% technical. Another blog entry I did, and this is a year ago, is a representation of maybe Servirtium's use in a client-supplier co-development. So your company could be a startup and you need payment services, and their company, the supplier, could be a payment gateway. Could it be Visa or MasterCard, or could be some other company that purports to give you a nicer API than those for commissions. And they might just to you be a supplier who are shipping a service to you, and they've given you one sandbox dev QA environment, and they've given you one production environment, and for a bunch of reasons you want to automate against their QA environment, but you find it slow and flaky. And this is a real life case for me more than once, and everyone I chat to about this says, oh, I'm immediately using it for my payment gateway, and I don't 100% like that service, but it is what it is and we're live with it. So they record it in QA, and then they get faster as a dev team by using playback super reliably, super fast, you know, always faster than their real service. But anyway, some pictures here of the bits and pieces that are made, and the blog entry talks to that more, and the constituent parts and what is the TCK. And, you know, if it was a payment gateway and you're a small startup, you don't get much of a input into what the supplier is making. But what if that partner only had you as their client and that you're co-developing this? Then maybe you've got a way of working on the TCK together, even ahead of the implementation by the supplier or ahead of the utilization of that service by you. So this blog entry goes into that. More reading 3, yet one more attempt at using graphics to depict this relationship between the real and the mock. And then, you know, I said it's open source and we're making it now. Now, when I was in ThoughtWorks, I found it easy to grab people that weren't currently billable and move them onto the Selenium team to do bits and pieces for this fairly large deliverable, because it was 4 languages originally, Java, Ruby, Python, .NET, and Java. And now we're at like 8 or 10 languages for Servirtium because more languages are relevant today. And I can't grab people from ThoughtWorks' unassigned beach or bench. So I have to find volunteers in the community, and two people who've recently stepped in to do a version each for me are a friend, Duong Pham, who's doing a Go implementation, and another friend, Dennis Karpovsky, who's working on a Rust version. And they're both pushing these forwards to the point where somebody could use them today. And literally, as I'm sitting here speaking to you, they're still coding those things, and I'll check afterwards to find out how far they got with their next piece of work. But we already have a bunch of them. So where am I? I've got 7 minutes to go. So I have a question slide, but what I'm going to do is I'm going to attempt to show you something for live. And did my screen change to IntelliJ? Can you see that? I can't see it.
Yes, Paul, we can see.
You can see IntelliJ, right? So we have a TCK, right? So this is going against World Bank's Climate API, and I hopefully don't take too long here to show you this stuff. But we have some prior recordings. This one here is a sort of file called Test Average Rainfall for France from 1980 to 1999 exists within the World Bank's API. So we have the recording, some headers that go up. It's a get. Some headers that come back, and some XML that comes back. So XML in the middle of this Markdown code block, and it's fairly long. So I'm bored already with scrolling through that. Over 100 lines of that, but that doesn't matter because the technology that was written to process that XML makes sense of it. And if I go to the test here, I've got a test in Go that says test average rainfall for, Great Britain. I just talked about France, different test. Test average rainfall for Great Britain from 1980 to 1999 exists. And it just so happens, and everyone should know this, it was 988 millimeters or feet, I can't remember which, of rain in that 2-decade period. Anyway, and this test would run and then pass against that or fail. We can make it fail by using that thing there, and let's run it. And in this case, down here, the test is going to run. Come on, speed it up, IntelliJ. There's a Murphy's Law of demos, isn't there? Come on, hamster, run faster. I think this thing down here is saying building, but it's hidden behind it. It says compiling. Okay, should be faster than this. I think it's because my little Mac is busy doing a presentation that it isn't the 5 seconds that it was previously. Okay, let's skip the running of that. And then remind ourselves that we have this in XML form here, and inside Markdown. But the way IntelliJ presents that, same as GitHub, is it shows you on the right-hand side what that would be if it was rendered. So we can hide that view. These are the recordings that have gone through. We have test base, things like that. And every project would typically look the same. It wouldn't matter whether this was a Go test or a Python test or Ruby or .NET. It's always going to be the same with a recording here. And it doesn't matter whether you use a unit framework like JUnit or a spec framework like RSpec or a second generation BDD framework like Cucumber. You're going to have these Markdown recordings that are coupled to the test in question. Anyway, so that's still compiling. No. Oh dear. I promise you that was really fast previously. Okay, so let's go back to the presentation, which it now doesn't want to do because oh dear, it's going very slowly. Come on. Where's the presentation gone? Is it down here somewhere? I can't get the presentation. There it is. Okay, so we're at the question stage. If anyone would like to dive into questions, I can look at my second monitor and see what the questions are.
Yeah, I think the first question is, can you talk little about trunk-based development in large-scale programs, more than 300 people? What are the prerequisites to move to TBD?
Yeah, so trunk-based development is what I'm more well known for. You know, really, a fast build is one of your prerequisite features of trunk-based development, and a team habit of keeping the build green, meaning we run that whole bunch of compilation, unit tests, service tests, functional tests, and they're always green, and that's always fast, like a matter of minutes. So if we're in a 300 size team, which is possibly where Google were before, when they were in their early days, they were still directly pushing to the trunk. They, add another couple of thousand people on top of that, and Google in their monorepo implemented a patch queue to allow them to do code review before stuff would get merged into the trunk. But 300 is the upper limit of what you can do pushing directly to the trunk. You're probably in 2020 going to be using a pull request feature of GitHub to marshal these same changes, fast build, always green. So they go through code review and then an automatic test using the same Jenkins infrastructure, but that build is not a CI build. When that one says yes, and then the code reviewers say this commit is good and it gets merged into the trunk, then you're in that high performance, high throughput place. So 300 people is merely a question of how fast is the build, how good is our team rigor around keeping it green, are we doing continuous review, can our CI infrastructure keep up with stuff that has landed in the trunk, and can the same infrastructure keep up with stuff that is about to go into the trunk, but that in itself is not CI. Those are your gates before you can say, let's do trunk-based development for a 300-person team.
Okay, I think we are.
So what I'll do is I'll drop the price of the book temporarily, so a whole bunch of you on this call can go and buy it if you want to. Okay. So we'll do 1 day from now. I'll put the price of the book back up again, but I'll go and drop the price now so you can go and buy it in the next 24 hours. But don't tell anyone else, right? So, make the Americans pay full price, okay? But India's going to get a big discount that's going to last a day. I didn't say that. Stop recording.
Yeah, I think. Okay.
Okay.
Thanks for
See you
sharing
later.
experience
Bye.
and knowledge, and all the concepts and the technique and experience on the service visualization is like a food of thought for us, and I think we can try that and see that how that is going to benefit us.
Yeah, and get involved.
Yeah,
I'm looking for volunteers.
Yeah, thank you. Thanks
Bye.
again. And one announcement. So after this session, I think we will be going to be having 2 set of tracks running. So we'll be having 3 tracks. First one is the culture and collaboration. Second will be the product stability. And the third will be the fast delivery. So all the details of the different talks as well as the speakers are available in the schedule. Please go and look at that and join the session, which is going to add more value to you. With that, I'm just going to stop this live now. Thanks everyone for joining. Thanks, Paul, once again. Thank you.